The LFMC is properly bonded by being connected at one end with a separate equipment grounding conductor run inside the flexible metal liquid tight conduit. The 2020 National Electrical Code (NEC) addresses this issue in section 250.102 E1, which states flexible metal raceway shall be bonded where it terminates at a metal enclosure or raceway. In this situation, the LFMC is terminating at a metal enclosure, the PVC conduit body. Therefore, it must be bonded at that point. The fact that there is a separate equipment grounding conductor run inside the flexible metal liquid tight conduit does not change this requirement. The equipment grounding conductor is providing a redundant path for the bonding current, but it does not eliminate the need to bond the flexible metal liquid tight conduit itself. The reason for this requirement is to ensure that there is a continuous electrical path between the flexible metal liquid tight conduit and the ground system. This path is necessary to prevent the accumulation of static electricity on the flexible metal liquid tight conduit, which could create a fire or shock hazard. Therefore, the LFMC is properly bonded by being connected at one end with a separate equipment grounding conductor run inside the flexible metal liquid tight conduit. Bonding and grounding are critical concepts in electrical safety and NEC compliance. Let's delve deeper into the requirements for flexible metal conduit bonding when used with an equipment grounding conductor. Firstly, it is essential to understand the purpose of bonding and grounding in electrical systems. Bonding creates a low impedance path for fault current to return to the source, allowing overcurrent protective devices to operate and clear the fault quickly. Grounding provides a reference point for the electrical system, minimizing voltage potential differences and reducing the risk of electric shock. The NEC provides detailed guidelines on how to properly bond and ground electrical systems to ensure safety and prevent electrical hazards. Section 250 covers the requirements for grounding and bonding, and it is crucial to understand these requirements to comply with the code. When using flexible metal conduit, LFMC, it is important to ensure that it is properly bonded to maintain the integrity of the grounding path. While the NEC does permit the use of the flexible metal liquid tight conduit itself as a grounding conductor under certain conditions, there are limitations on its use. Factors such as the length of the flexible metal liquid tight conduit, the size of the conductors, and the overcurrent protection rating must be considered. In many cases, it is necessary to supplement the flexible metal liquid tight conduit with a separate equipment grounding conductor to ensure adequate grounding. The equipment grounding conductor is a dedicated conductor that runs alongside the circuit conductors and provides a low impedance path for fault current. It is typically made of copper or aluminum and is sized according to the NEC guidelines. When using an equipment grounding conductor inside the flexible metal liquid tight conduit, it is important to properly terminate it at both ends. The equipment grounding conductor should be connected to a grounding busbar or terminal in the electrical panel and to a grounding lug or connector at the equipment or device being served. It is essential to ensure that the connections are tight and secure to provide a reliable grounding path. The NEC also addresses the bonding of flexible metal liquid tight conduit in section 250.102 E1 as previously mentioned. This section requires that flexible metal raceways be bonded where they terminate at a metal enclosure or raceway. The purpose of this requirement is to ensure that there is a continuous electrical path between the flexible metal liquid tight conduit and the grounded metal enclosure. This helps to prevent the accumulation of static electricity and provides a path for fault current to flow back to the source. There are several methods for bonding flexible metal liquid tight conduit. One common method is to use a bonding bushing or a grounding lock nut. These devices are installed on the flexible metal liquid tight conduit fitting and provide a secure connection to the metal enclosure. Another method is to use a bonding jumper, which is a short length of conductor that connects the flexible metal liquid tight conduit to the metal enclosure. The bonding jumper should be sized according to the NEC guidelines and should be securely connected at both ends. When installing flexible metal liquid tight conduit between a metal enclosure and a PVC conduit body, it is important to consider the grounding requirements for both the metal enclosure and the PVC conduit body. The metal enclosure must be properly grounded to the building's grounding system. This can be achieved by connecting the metal enclosure to a grounding electrode conductor or to the building's metal frame. The PVC conduit body is non-conductive, so it does not need to be grounded. However, it is important to ensure that the equipment grounding conductor is properly terminated at the PVC conduit body and connected to the equipment or device being served. In summary, when installing flexible metal liquid tight conduit between a metal enclosure and the PVC conduit body, it is essential to ensure that the flexible metal liquid tight conduit is properly bonded and that a separate equipment grounding conductor is run inside the flexible metal liquid tight conduit. The flexible metal liquid tight conduit should be bonded at the metal enclosure using a bonding bushing, grounding lock nut, or bonding jumper. The equipment grounding conductor should be properly terminated at both ends and connected to a grounding busbar or terminal in the electrical panel and to a grounding lug or connector the equipment or device being served. By following these guidelines, you can ensure that the electrical system is properly grounded and bonded, reducing the risk of electric shock and electrical hazards. Additional considerations when using flexible metal liquid tight conduit include ensuring that the flexible metal liquid tight conduit is supported properly. The NEC specifies the maximum spacing between supports for flexible metal liquid tight conduit, and it is important to adhere to these requirements to prevent the flexible metal liquid tight conduit from sagging or becoming damaged. Also, it is important to protect the flexible metal liquid tight conduit from physical damage. Flexible metal liquid tight conduit is susceptible to damage from impacts, abrasion, and other physical hazards. Therefore, it should be installed in a location where it is not likely to be damaged or should be protected with a suitable covering. When selecting flexible metal liquid tight conduit fittings, it is important to choose fittings that are listed for use with flexible metal liquid tight conduit. There are different types of flexible metal liquid tight conduit fittings available, and it is important to choose the correct fitting for the application. The fitting should be installed according to the manufacturer's instructions and should be tightened properly to ensure a secure connection. It is also important to consider the environment in which the flexible metal liquid tight conduit will be installed. Flexible metal liquid tight conduit is available in different materials and with different coatings to protect it from corrosion and other environmental factors. Choose flexible metal liquid tight conduit that is suitable for the environment in which it will be installed to ensure that it will last for many years. When working with electrical systems, it is always important to follow safe work practices. Wear appropriate personal protective equipment such as safety glasses and gloves. To energize the circuit before working on it, and use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Remember, electrical work can be dangerous, and it is important to take precautions to protect yourself and others from electrical hazards. Understanding the NEC requirements for bonding and grounding of flexible metal liquid tight conduit is essential for ensuring electrical safety and preventing electrical hazards. Always consult the NEC and other applicable codes and standards before installing flexible metal liquid tight conduit. Following these guidelines will help you to install flexible metal liquid tight conduit safely and correctly. The NEC provides specific tables and guidelines for sizing equipment grounding conductors based on the size of the overcurrent protection device. It is important to consult these tables to ensure that the equipment grounding conductor is sized appropriately. An undersized equipment grounding conductor may not be able to carry the fault current safely, which could result in a fire or shock hazard. In addition to bonding the flexible metal liquid tight conduit at the metal enclosure, it may also be necessary to bond other metal parts of the electrical system. For example, metal conduit, metal enclosures, and metal equipment should all be bonded together to create a continuous grounding path. This helps to minimize voltage potential differences and reduces the risk of electric shock. The NEC provides detailed guidelines on how to bond these metal parts of the electrical system. When installing electrical equipment, it is important to follow the manufacturer's instructions. The manufacturer's instructions may provide additional information on how to properly ground and bond the equipment. Following the manufacturer's instructions will help to ensure that the equipment is installed safely and correctly. Electrical inspections are an important part of the electrical installation process. An electrical inspector will review the electrical installation to ensure that it complies with the NEC and other applicable codes and standards. If the electrical installation does not comply with the codes, the inspector will require that the corrections be made. It is important to cooperate with the electrical inspector and to make any necessary corrections to ensure that the electrical installation is safe. The specific requirements for bonding and grounding of flexible metal liquid tight conduit may vary depending on the local codes and regulations. It is important to check with the local authorities to determine the specific requirements in your area. Following the local codes and regulations will help to ensure that the electrical installation is safe and compliant. Proper grounding and bonding are essential for electrical safety. By understanding the NEC requirements and following safe work practices, you can help to prevent electrical hazards and protect yourself and others from electric shock. Continuous electrical path between the flexible metal liquid tight conduit and the ground system. This path is necessary to prevent the accumulation of static electricity on the flexible metal liquid tight conduit, which could create a fire or shock hazard. The LFMC is properly bonded by being connected at one end with a separate equipment grounding conductor run inside the flexible metal liquid tight conduit.